Hi, everybody who's here.
Hello.
How are you?
Good. How about
I'm all right.
Hi, April. How are you?
I'm fine. How are you?
Oh, just waiting to get started. I'm all tremble.
Let's see. We were on this. That's weird. What? Mhm. Did anybody have any questions before I start? All right. Well, the other day we ended right here. We were in number 19, part B. So I am going to pick up from where I left off. And that took us to part C. And part C wanted us to multiply the two functions together. Let's see, what were the two functions? They were x minus 3 and 3x squared. Okay, so f times g of x means take f of x times g of x, and f of x was an x minus 3, and g of x, I've already forgotten, what was it? 3x squared, there we go, was a 3x squared. And of course, in order to multiply this, I'm going to have to distribute the monomial through the binomial. So 3x squared times x is 3x cubed, and 3x squared times minus 3 is a minus 9x squared. And so that's what you'll just type in right here for choice A. Sorry, I had to go get my paper over here. This will be easier so I can just look at it instead of jumping back and forth. 19, and 19. Okay. All right, so that was part C. And then it went on to part D. F over g of x means take the f of x function and divide it by the g of x function. And of course, the f of x function was just x minus 3. And g of x was 3x squared. And absolutely nothing can be simplified on this because you've got a binomial in the numerator and a monomial in the denominator. You cannot cancel the 3's and you cannot cancel the x's because of this subtraction, right? That's the only thing you can cancel an x minus 3 with is another x minus 3. It's all or nothing. So that's part D. And was there more to this? Oh yeah, I kept going. Okay, now part E says calculate f plus g of 2. And we had already calculated f plus g way back here in part A. When we calculated it, we got, and I just put it in descending order, 3x squared plus x minus 3. So this is actually f plus g of x. And they want f plus g of a 2. So wherever there's an x, you're going to be plugging in a 2 like that. Plug in the 2. So I'm going to end up with, let's see, this is going to be 3 times 2 squared is 4. 3 times 4 is 12. And then from left to right, 12 plus 2 is 14, and 14 minus 3 is 11. And so 11 is the answer to part E. And then part F wants f minus g of 4. And earlier we had calculated f minus g of x. That was, where was that one? That was part B. When we calculated it, I got negative 3x squared plus x minus 3. Okay, but they want you to calculate f of f minus g of a 4. So wherever there is an x, I am going to put in a 4 and then simplify it. So this is going to be negative 3 times 4 squared is 16. And then multiply next, that's negative 48. And then go left to right. Negative 48 plus 4 is negative 44. And then negative 44 minus 3 more is negative 47. It looks like it keeps going. And then they want f times g of 3. Well, when we calculated a few minutes ago, f times g of x, that was 3x cubed minus 9x squared. And so now what they want us to do is f times g of 3. So wherever there's an x, I am going to plug in a 3. Just take out the x and stick in the 3. Now it's order of operations. Or just plug it all into your calculator, but I like to show a few steps. 3 cubed is 27. And 3 squared is 9. And 3 times 27 is 81, and 9 times 9 is 81, and 81 minus 81 is 0. Oh man, we just did that problem for nothing. Get it? We get an answer of 0. Did it for nothing. Okay. And then H is F divided by G of 2. And just a few minutes ago, I calculated F divided by G of X, in which we got X minus 3 over the 3X squared. So now we're going to calculate F divided by G of a 2. So you're just going to stick a 2 wherever the X is. And of course, in the denominator, I'd have to put it in parentheses. So my numerator is going to be a 2 minus 3 is -1. And then my denominator is going to be 3 times 2 squared is 4. So that's 12. And that's my answer, a simplified fraction, -1/12. And that finishes that up. So questions on that? I pretty much just took the answers for, what was it, A, B, C, and D to do E, F, G, and H. Plugging and chugging. Which means if you get A, B, C, D wrong, then that's going to probably screw up E, F, G, and H. So try to make sure you get those first 4 right. All right, which brings us to the last objective from this section, which covers something called the difference quotient. And this is kind of a segue into a calculus class, because one of the first things you cover in a calculus class is the difference quotient. So for those of you that have to move on and take brief calculus, you're going to see this again. But anyway, there we go. Come on. What's going on with my computer? There we go. All right. They call it the difference quotient because the difference is right here. You're going to calculate f of x plus h and then subtract f of x. And then that's all going to be divided by h, as long as h does not equal 0. And basically what this is quick picture here. If you have a curve on a graph, doesn't matter what it looks like, and there are 2 points here and here, and this one has this x coordinate and this x coordinate. We'll call this x sub 1 and this x sub 2. And then they also have their y coordinates. This will be y sub 1 and y sub 2. You're basically looking at the average rate of change going from one point to the next in this curve here. But what they do is they usually set it up as what's called a limit. Now we're not doing limits, but they're going to move, get a green color here. They're going to move this point here from here to here, from here to here, and it's going to get closer and closer. And as they move it, the distance from here to here is actually going to be h. And as h gets smaller and smaller and smaller, it actually gets closer to being 0 and 0 and 0, and the calculation changes. And as you get closer, you get to what they call the limit. Anyway, that's what this formula is all about. So right now, you're just being introduced to the formula. You're going to mess around with the math and just practice it. But if you take a calculus class, you'll learn more about it there. So anyway, it says find the difference quotient of a function, and they want you to do it for all 3 of these. So basically, you're just plugging and chugging the x plus h into the function. And on part A, the original function for f of x was 2x squared minus 3x. And you can see that they have placed an x plus h where this x is, and an x plus h where that x is. And of course, back here is the entire, it's minus the entire function of f of x, which is back here. But up here, you had to plug in x plus h, where the x's are. And then basically, it's just a lot of algebra and simplifying. They FOIL, they distribute, they combine like terms. Then they, from here to here, they factor out the h so that they can cancel it here. And then this is the difference quotient is what they got. And in order to save a little time, here's part B. The math is just a little bit more complicated, but this time the f of x, the original f of x function was just 4 over x. And they put the x plus h where the x was. And then of course it's minus f of x. This is f of x. And then they had to get a common denominator. I would have cleared out the complex fraction. And if I have an example like that, I'll show you. And actually, I don't think I do. No, they got a common denominator, and then instead of dividing by h, they multiplied by 1 over h, which puts the h there. And then they ended up canceling that, and that's how they got this answer. There's more than one way to solve these. And then what they do in this one? The original function for this one was f of x is equal to the square root of x. So for f of x plus h, they put the x plus h underneath the radical right there. And then it's minus f of x. And then, looks like they rationalized the numerator. Oh, yeah, that's right. Because h can eventually in the limit get closer and closer to 0, you can't just leave the h by itself in the denominator. So that's why they rationalized the numerator. Remember, this one's a minus, so they multiplied it by its conjugate. That's what rationalizing does. You multiply it by its conjugate. But they have to do the same thing to the denominator. And then when they were done rationalizing the numerator, all they got left was an h, which canceled this h. And now, when you do the limit, you'll stick a 0 where h is. If you take the limit right here and you stick 0 in, you can't have that because you can't divide by 0. So you've got to get that out of there. But again, that's a calculus thing. Right now, you're just practicing the simplification. So let me do, this is Mymathlab number 21. It says find the difference quotient of f of x equals x squared plus 6. And of course, the difference quotient is f of x plus h minus f of x all over an h now behind the minus sign, I have f of x. Well, f of x is x squared plus 2. So back here, and you have to put it in parentheses because it is behind the minus sign. That means you're going to have to distribute. You're simply going to write the entire function of x squared plus 6. However, in front of the function, use light blue, I have an f of x plus h. That's what's going to go here. And you're going to use the f of x function, but in place of the x, which is here and here, you're going to put an x plus h. So instead of x squared plus 6, I'm going to have an x plus h squared plus 6. Yeah, I'm still here. I was just pausing for a moment. Let that sink in. Normally at this point when I look out, I see a lot of confused faces, but I can't see anything from here. Now that's the initial step of substitution into the difference quotient. And now I have to do my simplifying, and I am going to start by simplifying. What would be a good color to put on top of this? Maybe dark gray. I'm going to do this part right here. I'm going to take the x plus h and square that. Okay. I'm going to do it up here. I'm going to take an x plus h times another x plus h. That's this right here. It's like my scrap paper. And that means I'm going to FOIL. So x times x is x squared. My outside would be an hx. My insides would be an hx. And my last times last is h times h. That's an h squared. And I can combine these two. That would make two hx's. So now I'm going to have x squared plus 2hx plus h squared. This is what I got when I did the gray stuff. But I still have this plus 6 right here. And while I'm at it, I am going to distribute this minus sign through the back set of parentheses. That's going to be a minus x squared and a minus 6. But keep in mind that this is still all over h. And now I'm going to simplify my numerator, still all over h. Some stuff is going to cancel out. Let's see, how about yellow? All right, this x squared and this minus x squared, those will cancel out. And this 6 and this minus 6, those will cancel out. So all I will be left with is the 2hx plus h squared. And then you can factor out the h from the numerator, because both terms in the numerator, this 2hx, it has an h, and my h squared has at least one h. So I can pull that h out, leaving me with a 2x and plus the other h. All over an h. And now once you factor that out, now you can cancel out the h's because they're both monomials right there. So that your difference quotient is a 2x plus h. That's my answer. And that finishes, yeah, question?
Excuse me, you said 2hx plus h2. You could actually cancel one of the h's out with the h from the 2hx. I never saw that before. And you had a parentheses with the 2x plus h. Is that what you said?
Yeah, I factored out the h.
In the step, like 1, 2, 3 steps back, you have the 2hx with a red and then the h squared. And
Yep. There's an
can you go from there again? I'm sorry. I'm not sure what you said.
Oh, I just highlighted them in like a light gray color. both of those terms have an H in common. So I factor out the common H right here, which is me.
Okay.
I'm like greatest common factoring it out.
Yeah. Okay, I've never seen that way before. Okay.
Now there is another way to do it. I could have, let's see, let me put it in a different color. I could have,
I just went with the H on the step before that and canceled there.
like this.
Yes, exactly.
Yep, you can do that too. And then you cancel this H, and then this one cancels out one of those.
Exactly. Yeah, that's what I did.
Yep, and you're still left with 2x plus H. It's like, that's like you're distributing the division.
Just in a different place. Yeah.
Yep. Or you can factor out the H. Because when you factor out the H, you create multiplication right here where I'm drawing this dot. And then you can cross cancel here. But I could not have cross canceled. I could not have cross canceled this H with this one because of this addition sign right here. That stops me from canceling. You can only cancel factors. And when you factor out this H here, then you can cancel this one and this one. Anything else? All right, so that finishes 3.1. And can you see 3.2 now? I switched over to it. Or maybe you can't. I don't know. Can somebody let me know if you can see 3.2?
No.
Okay. I don't know why it does this to me. Share screen 3.2. Now can you see it? Can you see 3.2 now?
Yes.
Cool. Thank you. All right. This is a pretty short section. So it's possible I may even be done early today. Woohoo! It only covers the graph of a function, and we're going to identify a graph and get information from that graph. So objective number 1 is identify the graph of a function. And I actually talked about this the other day, the vertical line test. A set of points in the XY plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. So if you can find a spot where you draw it and it hits it in 2 points, that graph is not a function because you just found 2 points with the same x coordinate. So here's 4 examples. The dotted line is the line they're drawing. So here they drew a dotted line. It only crosses it once right here. Here's a dotted line. It only crosses it once right here. No matter where you draw it, it only crosses it once. So A is a function. On B, no matter, they only showed one picture, but they're drawing it once here. It only crosses it at one spot. But even if I drew it here, it would only cross in one spot. Or over here, it would only cross in one spot. So B is also a function. But when you get to C and they draw the dotted line, it crosses it in 2 spots here and here. So this one's not a function. And this one also crosses it. Circles are not functions either. That's not a function because it crosses it in 2 places. And then the next slide pretty much just says everything that I just said. The graphs of figures 14a and 14b are graphs of functions because every vertical line intersects each graph in at most one point. But the graphs in figures 14c and 14d are not graphs of functions because there is a vertical line that intersects each graph in more than one point. And then they just wanted to point out in figure C that the input 1 corresponds to two outputs, -1 and +1. They even labeled them, didn't they? Yep. They're showing you here that the input of 1, both of these points have an input of 1, and then they give two different outputs, 1 and -1. And that goes against the definition of a function. So the input of 1 corresponds to two outputs, -1 and +1. So that's that. Now, obtaining information from or about the graph of a function. They've got a big old example in here. It says, let f be the function whose graph is given in figure 15. Figure 15 is on the next slide. And they've got parts A, B, C, D, E, F, and G. They want you to find the answers to all of this. They want what are f of 0, f of 3 pi over 2, and f of 3 pi. So if I start with f of 0 and I go to the next slide, you want to find the point that has an x coordinate of 0. X coordinate of 0 is right here. So f of 0 would be 4. So part A, when they say what is f of 0, the answer is 4. It's that right there. And then the second part was what's f of 3 pi over 2. So you want to go back and look for the x coordinate, that is 3 pi over 2. 3 pi over 2. That's this one right here. That's this point, 3 pi over 2. I meant to underline that, sorry. 3 pi over 2. So f of 3 pi over 2 would be 0. So for the second part, that's going to equal 0, which is here. And then there was one more. What was it? They wanted f of 3 pi. All this pi is making me hungry for pi. So I look for the x coordinate. That's a 3 pi, and that would be this point. There's the 3 pi. So f of 3 pi would be -4. So get it right there. And of course, if you go down to where it says solution, that's slide number 10. There's my answer. Since 0, 4 is on the graph, the y coordinate 4 is the value of f at the x coordinate 0. That is what I just said. Whoops. F of 0 is 4. And then in a similar way, when 3 pi over 2, blah, blah, blah. So right here, that's equal to 0. And then the last one I did in pink, x equals 3 pi, blah, blah, blah. So there it is. There's all their answers. All right, so going back to slide 8 again, I kind of have to jump around, unfortunately. Part B says, Find the domain. What is the domain of F? Now the domain is where this thing, it's how this thing spreads out over the x-axis. And when I look at this chunk of graph, the graph starts right here and ends right here. So the x coordinate of this point is the beginning of my domain, and the x coordinate of that point is the end of my domain. And because these are solid dots, I would need a bracket on this. So my domain, I'll just say D, well, the domain is going to be from 0 to 4 pi, and I would need brackets for both because of the solid dots. And if I go to their explanation on part B, the domain is, first they put it in set builder notation, and then they put it in interval notation, which is what I did, from 0 to 4 pi. And I guess, what's the next one? C wants to know, what is the range of F? And that's how it stretches vertically. So I go back to the graph and I have to look for the highest and the lowest and highest points. Remember, intervals go from smallest to largest. Same thing with the inequalities, from left to right, smallest to largest. So the lowest point on this graph is right here. I got two of them. They both have the exact same y coordinate. It's -4. And then the highest point is right here. I got 3 points, but look, 4, 4, and 4. They're all the same. So my range goes, and they're all solid dots, so I need brackets, goes from a low of -4 to a high of +4. And if I go and look at their explanation, I'm assuming I put it in both interval. Yep. Here's C, here's my interval, -4 to 4. But this is what it would look like if it was in interval notation. Between -4 and 4 with less than signs. All right, what's next? D. List the intercepts. Okay, we're going to list the intercepts. Recall that these are the points, if any, where the graph crosses or touches the coordinate axes. So you can have x-intercepts and y-intercepts. And this graph is getting more and more colorful as I go along. When I look at the y-axis, this is the only point that is crossing the y-axis. So this point right here is my y-intercept. When I look at the x-axis, I've got 1, 2, 3, 4 x-intercepts. This point, this point, this point, and this point. Those are my x-intercepts. That's an x-intercept, 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 x-intercept. So 1y, 4 x's. Let's see, this would be back on slide 11 now. I think that's where their part comes up. Yep, the intercepts. There is my y, 0, 4. And then the rest of these are x, and then y is 0, x, and then y is 0, x, and then y is 0, x, and then y is 0. So those are my intercepts. Okay, we're going back to the questions. Let's see. E says, how many times does the line y equal 2 intersect the graph? How many times does the line y equal 2 intersect the graph? Okay, y equals 2, that's a horizontal line, and it would go through the y-axis at 2. So if I draw it going straight across here, it crosses it 1, 2, 3, 4 times. So the answer is 4. I probably should have copied this picture a few times and instead of trying to do it all on one drawing. Let's see what their answer is. Draw the horizontal line. Notice that the line intersects the graph 4 times. There you go. All right, we got 2 more, F and G. F, for what values of x does f of x equal -4? Okay. Let's pick another color. How about dark green? Okay, so F, for what values of x does f of x equal -4? We are looking for the points that have a y coordinate of -4. And we're wanting to know that for what values of x does f of x equal -4? Remember I said the other day, f of x is really just your y coordinate. They just like, it's called functional notation, or as I like to call it, higher level PhD bullshit. You know, they're just trying to make it more complicated. So I have to go back to my graph and look for any points within y coordinate of -4. And there are 2 of them. This one here and that one there. And we want the x coordinates, so we need the pi and the 3 pi. Pi and 3 pi should be the answer to that. So I'll go back and look at their solutions just to double check. Here's F. And when x is equal to pi and x is equal to 3 pi, there they are. I must know what I'm doing. And the last one is G. For what values of x is f of x greater than 0? Okay, so we're looking for y's that are greater than 0. We're looking for all points that have a y coordinate that's greater than 0. Doesn't that mean if you're looking for y's greater than 0, if you're looking at the XY coordinate grid, anywhere there's a y greater than 0, wouldn't that be above the origin in quadrants 1 and 2? That's where y is greater than 0. Now you could have positive x's or negative x's, but all of the y coordinates are positive in quadrants 1 and 2. So I'm going to go back to my graph and I am looking for any point that is greater than 0. Now I'm looking, all of my graph here is in, is in the first quadrant, right? It's in the first quadrant or the fourth quadrant, so I only want first quadrant stuff, but I cannot include the ones that have a 0, which would be this one and this one. I can't use those because it didn't say equal to. It only said greater than 0, not equal to 0. So the ones that are greater than 0 would be this point and this point, and this point. Did they want them as ordered pairs? 0, 4, 2 pi 4, 4 pi 4. Wait a minute. Let me go back and read it. So, for what values of x it? Oh. My bad. They want all of them, just not the ordered, just not the points. Okay. Let me see if I can. Nope, that ain't gonna work. Hang on a minute. Okay, I need a blank graph for this. This is gonna be part G, okay. G, this is part G. All right, so once again, I'm looking at this quadrant. Okay. And I want all points that have a y coordinate greater than 0. I cannot use this point or this point or this point or that point because they're equal to 0. But I can use any of these points, any of these points, and any of these points. And that's actually an infinite number of points there. I can go anywhere, and when you're listing all of the x's, so you have to look at the x-axis going from left to right, but this is 3 different intervals. I'm starting at the 0, and let's see. From 0 to here, this is 1 interval. That goes from 0 up to pi over 2, but I cannot include pi over 2 because that one has a y coordinate that is equal to 0. And then you got to use that union symbol. Then you're going to go on the other side of, well, need different color, sorry. Then I'm going to go to this interval, right, which goes up and then down. So it's going to cover everything in between here, going from 3 pi over 2 to 5 pi over 2, but you cannot include the 3 pi over 2 or the 5 pi over 2 because that would be an equal to 0. Then another union. And then I got one more. It's going to be this interval here, which starts at 7 pi over 2 and ends at 4 pi, but I'm allowed to include the 4 pi. I cannot include the 7 pi over 2 because it has a y coordinate equal to 0. And then 4 pi I can include because its y coordinate is greater than 0. So that should be my answer. Is it? 0 over pi over 2, 3 pi over 2, 5 pi over 2, union 7 pi over 2 to 4 pi. There it is, right there. Here's this one. Here, come on. There's that one. And that one. which I don't know why I used bright pink at the beginning of it. I don't know, I'll just leave it green, whatever. There's those. Does that make sense when you're looking at it now? Now you can see why I had to recopy it, because there's too much color. Could you imagine me trying to put that on top of all that? I probably should have copied this picture once for every single one, but I didn't. All right, and then one last thing, because when I was looking at your Mymathlab, there's some questions that ask you about symmetry, but yet this right here was actually the last slide to their PowerPoint. So I went on the internet and I found this and I just stole it, and I probably should have put, you know, where I found it from, but I didn't. Oh, report me to the math police. But symmetry, the best way I can explain symmetry to you is to take you back to like first, second, third, fourth grade. You know, when you used to have Valentine parties and your teacher would hand out a piece of paper and you would fold it in half, and then you would take your pencil and you would draw this shape, and then you would pick up your scissors and you'd cut along that shape, and when you opened it up, and I'm not doing a very good job, but you'd have a perfect heart. It would match on both sides. Well, the line of symmetry is this line right here. The line that cuts the picture in half and makes a perfect mirror image is called symmetry. And so there's three pictures where here's your line of symmetry for this graph. Here's your line of symmetry for that graph. And I know this is going to look weird because it's not in the picture, but here's your line of symmetry for this graph. There's actually two lines of symmetry. It could be that one, because you could fold, if you can fold the paper over and have it match, it would go like that, but you could also fold it on this diagonal and this curve here would match on that curve there. But anyway, that's all line of symmetry is. Okay, it's a mirror image. So when we get to that, I may have to refer back to this slide. So now I'm going to move on to the Mymathlab junk. Mymathlab number 2 starts out very simple. It says, state whether the following statement is true or false. The point, -4, -4, is on the graph of the equation x equals 4y minus 5. The way you do this is you take the x coordinate, which is -4, and you plug it in place of the x, and you take the y coordinate, which is -4, and plug it in place of the y. I took out y, I plugged in the y coordinate. I took out x and I plugged in the x coordinate. They just happen to be the same number, -4. And now you have to check, does the left side really equal the right side? Because it's saying that x is going to equal 4 times whatever y is minus 5. Well, the left side is just -4. The right side, I'd have to follow order of operations. 4 times -4 is -16. And then -16 minus 5 is -21. -4 does not equal -21. So that's a big false. That's all there is to that kind of a problem to see if it's really a solution. To see if it's on the graph, you would have to check in the equation. Any questions on that? I can't see the chat box because I kind of closed everything out. So if you have a question, you're gonna have to pipe in. You're gonna have to unmute yourself.
All right.
Complete the sentence below. If the point 4 comma -1 is a point on the graph of f, then f of blank equals blank. All they're having you do here is changing your ordered pair into functional notation. But keep in mind that most ordered pairs are listed as x and then y, but that's the same thing as saying x comma f of x. So the x coordinate is still the 4. The f of x is the same thing as your y coordinate, which is -1. Okay. And the way this is written over here, this is f of, you're supposed to put the x coordinate here. This is always f of x. So x is a 4, and then it's going to equal the y coordinate, which is -1. Put the x coordinate where in the parentheses, because that's supposed to be f of x, and then it's going to equal the y coordinate because that's what f of x is. It is the y coordinate. So you just stick the 4 in the parentheses and the -1 in the answer spot. That's all there is to that. Okay, now I was smart enough on example 6 because it asks 3 questions about the same picture. So I kept recopying the picture over and over so that I could draw on it and not have so daggone many colors on it. But first it says, determine whether the graph below is that of a function by using the vertical line test. That's the first question. They want to know, determine whether it is using a vertical line test. So here's your first question. Is the graph that of a function? Well, if I were to draw a vertical line anywhere, it only crosses the graph once. And remember, your function starts here, goes up and goes down and stops there. So no matter where I draw a vertical line, it's only crossing it one time. So yes, it is a function. So since we determined that it was a function, because it says if it is, then use the graph to find, and you got parts A, B, and C. Now, if you had come up with the answer of no, when you get to the next part, you would simply click on choice B, the graph is not a function. And then on part C, you'd click the graph is not a function. And then on part D, you would click the graph is not a function, okay? But we found that it was a function. So now I have to actually answer the rest of these questions. So part A, this is part A. Sorry, I didn't put that there. Select the correct choice below. What is the domain and what is the range? And they want your answers in interval notation. So don't be using set builder with the inequality signs. Do the interval. Okay, so remember that the domain goes from left to right. Bad job over here. There you go. So my graph goes from left to right all along here. So it starts right here and it goes to here. All of this is my domain. My domain goes left to right. And this may have been a mistake to use this bright of a color. Sorry about that. So I'm going from -pi to +pi. This is -pi here. Yeah, too bright. Sorry about that. This is +pi at this end. And because they're solid dots, use brackets. Okay. Now, the range. Try to use a bright green. to do the range, that's your lowest point to your highest point. My lowest point is here. Oh, this is a really bad idea. And my highest point is there. So it comes out black. Oh, great. Yeah, I'm sorry. Should have used a much lighter color for this. Domain. Okay, domain goes from left to right. And I'm looking at all of this from left to right. Those are all of my X's from left to right. Okay, so that was negative pi to positive pi. All right, and then for my range, boop, you're gonna go the lowest point here to the highest point there, because your range is from bottom to top going this way. So my points with the lowest y coordinate would be this -1. -1 is the lowest, +1 is the highest. So I'm going from -1 to +1. And just to clarify on the other one, on the X, this was my furthest to the left point, which has an X coordinate of -pi, and my furthest to the right point has a X coordinate of +pi. So that's my domain and my range. Did that make any sense?
Yes.
All right, cool.
Yeah, it did.
You know, I thought when you mixed, pink and blue, you'd get purple, but I didn't really get a purple color there. Kind of disappointed in that.
Nah, you mix red and blue purple, but the pink is a little bit too light to do that.
Man. All right, B. B says, what are the intercepts? And remember, it could be X or Y intercepts. So look for them all. I usually start with my X because there's usually only one. Well, yeah, if it's a function, there should only be one Y intercept. Because if there's more than one Y intercept, you just found 2 points with the same X coordinate, which would not make it a function. Because it wouldn't pass the vertical line test. If I had another point down here and then I drew a line through it, it doesn't pass the vertical line test. So you can only have one Y intercept, and that's this one here that has the coordinates X is 0, Y is 1. Let's see, type an ordered pair, type an exact answer using pi as needed, and use a comma to separate your answers as needed. So there's my first one. And now I'm going to go look for my X intercepts. There's 2. This one here, it has the X coordinate of -pi/2 and Y is 0. So that's my next one. And then I have one more Y coordinate and I have one more X intercept. It's this one right here. And that is X is +pi/2 and Y is 0. That's it. Those are my 3 intercepts for that chunk of the graph. And then comes part C, which was determine if the graph is symmetrical. You just have to look at it and see, is there a point where I could fold this graph in half where the right side would meet the left side. And yes, indeedy, there is. That line would be right here. Because this point is negative pi to the left, and this point is positive pi to the right. They're the same distance. And so is this point and this point. This is negative pi over 2 away from that line, and this is positive pi over 2. They're both pi over 2 distance away. They're mirror images of each other. So it says, is it symmetrical with respect to the x-axis? Is it symmetrical with respect to the y? Is it symmetrical with respect to the origin? The graph is not symmetrical. The graph is not a function. What I highlighted is what it is symmetrical with respect to, and it is symmetrical with respect to the y-axis, because it would be, you would fold it along the y-axis to see the symmetry, where the right side matches up the left side. Does that make sense? Wherever it is you fold it. Now, part C says the origin. Let me slide back to that one picture I added. Yeah, it was this one. When you fold it on a diagonal, that is where it's symmetrical to the origin. Whether you're folding it along this line or that line, both of them go through the origin. So in that type of a picture, you would say with respect to the origin. This one is respect to the y-axis. And then this one was with respect to the x-axis because of how I would fold it. And in my little heart picture, you know, since it's kind of vertical, I guess you could say it's like the y-axis because it's vertical. That's how you hold a heart up anyway, so. All right, so what do I got here? Next. Answer the questions about the following function. And this is my last example, but there's 1, 2, 3, 4, 5. You can see it. They want you to answer parts A, B, C, D, E, and F. So I got 6 slides altogether. Part A says, is the point 211 on the graph of F? And here's I did a screenshot of the answer part that should pop up for that. All you have to do is take the function f of x is equal to 4x squared minus x minus 3, and you are going to substitute the 2 goes where the x's are, and the 11 goes where the f of x is, because f of x is really your y coordinate. And then over here, I'm gonna plug in chug the 2. And now I have to figure out, does the left side equal the right side? So let's see, 2 squared is 4, 4 times 4 is 16, 16 minus 2 is 14, 14 minus 3 is 11. 11 equals 11. So what are my choices? I know it's yes. Yes, because substituting x into 2 into the given equation results in an 11. That's what I did. I substituted x is equal to 2 right here. And I got the 11 into the equation results in 11. So it's B. B for boy, that was easy. Okay, next one is part B, and this one says, if x is equal to -2, what is f of x and what point is on the graph of f? And here's the answer box that I would find. You're going to get a lot of positive affirmations on this one, 6 of them, because you keep entering the answers and then it, you know, pops up the next answer for you. If x equals -2, all right, Well, I'm going to take the -2 and I'm going to plug it in here and in here. Oops. And see what it equals. I'm going to plug it in here and plug it in here. -2 squared, -2 times -2 is +4. So that's 16. When you subtract a negative, you're really adding a positive. So that's 18, and then 18 minus 3 is 15. So when x is -2, remember f of x is really your y coordinate, that's 15. And they want you to type that as an ordered pair. So -2, comma, 15. And part C says, if f of x equals -3, what is x and what points are on the graph of f? And here's the answer box. Now, this time they're telling you what f of x is. So when they say f of x equals -3, that's the same thing as saying y equals -3. You are literally going to put this -3 where f of x is. So follow me. I'm going to put -3 right there. And that's going to equal 4x squared minus x minus 3. And I have to solve for x. That's a quadratic. I got to set it equal to 0. Pray that it factors. So I'm going to add 3 to both sides. Oh, cool. That cancels, and so does that. So I'm going to get 0 equals 4x squared minus x. The only factoring I can do on this is greatest common. They both have an x in common. So I pull out the x and I am going to be left with 4x minus 1. So my two possible answers are, for this x right here, it's just flat out 0. But for this x, it would be, I'd have to add over the 1 and then divide off the 4. So positive 1/4. Let's see, when you go to put your answer in, simplify your answer, use a comma to separate answers as needed. So I would put 0, comma, 1/4. And then using the information, list the points on the graph. So these are my x coordinates, right? So my 2 points are going to have the same y coordinate, which was the -3. But I'll put the 0 here and the 1/4 there. You all still doing good? Doing good?
Doing well.
Awesome. And then D wants to know what the domain of F is. Okay. There's no picture on this one. Okay. What's the domain of F? Here's the answer box, and it said type it in interval notation. Hopefully you guys can look at this and know what it is. This is a parabola. Because I have a positive 4x squared, it's a positive quadratic, which means it is a smiley face like this. And no matter where I draw the x and y axis, it really doesn't matter where you draw it as far as the domain is concerned, because this thing goes, I know it's pointing upward, but as it goes up, it goes out, doesn't it? Eventually, as it goes up, it keeps going out. So it spans the x-axis all the way to the right, and the same thing going this way. It goes out, so it'll go all the way to the left eventually as it spans out. So this sucker, parabolas, all parabolas have the same domain, negative infinity to positive infinity. Whether they're smiling at you or frowning at you, they stretch across the entire x-axis. The range is different. The range is, depends on where that curve is. So that's more complicated to find. But the domain, all real numbers, baby. Questions on that? All right, and E, list the x-intercepts. The x-intercepts are where they cross the x-axis, and the y-coordinate is always 0. All right. So for this one, I'm going to have to let y be 0. You're going to stick 0 where f of x is. And then it's already set equal to 0, so either factor or use a quadratic formula. And I think I can figure this out. If I put 4x here and x there, that's 4x squared. And then if I put the 3 here and the 1 there, that would give me 3, but it's got to be a -3 here and a -1. So I'm going to put the plus and the minus, and yep, -4x on the outsides, +3x on the inside gives me -1 in the middle. So this one is going to be subtract 3 divided by 4, and this one is just add over the 1. So my x-intercepts are -3/4, comma, y is 0, comma, 1, 0. And then, so that's that one. And then the last question, F, is list the y-intercept. And the y-intercept, I don't remember what color I've used. I'll just go with this light color. List the y-intercept. The y-intercept is when x is 0 and then it's somewhere on the y-axis. So you're just going to stick 0 where x is. And of course, that's going to be 4 times 0 squared minus 0 minus 3, which is just -3. So it's going to be 0, comma, -3 for choice A for this one. And right, I finished and I'm right at 5:15. Woohoo! Anybody have any questions?
Could you go over number 4?
4 from my PowerPoint or 4 from my Mymathlab?
Mymathlab. I couldn't do it.
Okay, let me, from this section?
Yes, 3.2.
All right, let me see if mine's still open. Go to assignments. 3.2, number 4. Let me go back to Zoom and share my screen.
Specifically on
right.
part F.
Okay, and I also need this in here. Okay, let me do something. I figured something out earlier today, so stop the share and now share again on this screen. Okay, there we go. I needed to get my whiteboard up there so I could draw, because I can't draw on the Mymathlab, unfortunately. It says, unfortunately for me to do this, I have to go through it all, I think. Wait a minute.
Yeah.
You know what? Let me see. Hang on. I'd actually printed it out too. So let me go to my Mymathlab assignment, see if this will work better. And I can just go straight to F. Yeah, this will work better. Number 4, F. Okay. All right, I had printed out number 4, and you want F, where it says for what values of X is F of X greater than 0?
Yeah.
Okay, and I can't draw on this either. Okay, hang on. Print screen. The things I have to do. Technology. Paste.
So annoying.
And make this bigger. And make this bigger. Okay, this should work, I think. All right, I'm in my Microsoft whiteboard. I did a copy and paste, so hopefully this will work. F, for what values of F, come on, highlighter, is F of X greater than 0? So you're looking for all the points that have a Y coordinate greater than 0. That would be any point above the X-axis, which I've highlighted them.
Yeah.
But it doesn't say equal to, so you cannot use that point or that point or that point with a bracket. You have to have braces or a parenthesis on it.
So I tried to do it with the with just the x-intercept. Is it asking for the entire points every single time?
The entire interval from here to here. So you're going to go from, oh, my green pen, hang on a second, green. You're going to start at this point, but you don't include it, and you'll end at this point. So that is -6. So you're starting at -6, and then you're going up to the -1. That is this whole interval going from here to here, and every point in between. Every single point on here, there's an infinite number of points. So every single point on there has an X coordinate that goes somewhere between -6 and -1.
Okay.
And then you do the same thing with this interval here, just that little piece. It goes from 4 to 6, right? All this in here goes from 4 to 6, but you're really just looking at all the points on this chunk. So that's 4 to 6, but you can't include, actually you can include the 6, my bad, because the 6 is up here and that would be greater than, so you can include that. The 4 is not greater than.
Would there be a union between them?
Oh, use a, no, it's a, type a compound inequality, use a comma to separate your answers. Okay, I put them in interval. If they want a compound inequality, let's see, for this one it would be -6 is less than X is less than -1, comma, and then this one would be 4 is less than X is less than or equal to 6.
All right, that makes a lot more sense. Thank you.
Remember, I can't use these because it didn't have an equal to here. So you have to see them as if they're open circles, even though I know they're solid dots. They were specifically asking what points have y coordinates greater than 0. -6 and -1, these 2 points circled in red have y coordinates equal to 0, not greater than. So,
All right.
and same
Okay.
thing with this guy. He's an equal to 0 also. But the 6, that's a greater than 0, so I can include the equal to on him. All right.
All right. Yep. That's good for me. Thank you.
Anything else?
Not that I can think of currently.
Okay. All right. Well, I'm done.
All right.
Have a good
See
night.
you
Bye.
on Monday.
Okay. Kellen, did you have a question? Kellen, are you still there or did I put you to sleep? Yoo-hoo! Kellen. I guess I put him to sleep. I'm ending the class now. Bye-bye.